going to do this together. Hey. We're up to 7. Good job.
You have a pen?
So you
Do you have a pen?
I got a. Let's see, I got a pencil. Here, I got a red pen. You want to use the red pen? All right, and again, if you need a bar calculator, please do that. We're going to do this together in the calculator part of it. So, whenever we go over something brand new, I do obviously take you through the derivation of where the equation comes from. I am not somebody who can just say, this is the equation, you plug shit in. No, I want you to see where it comes from, right? The minute we're done with that derivation, you can start to notice when it makes sense to use which equation. So I had some people using this equation up here. That doesn't make any sense, right? Which two equations make the most sense that would be used up here? Because what information do I give you? I give you x's and p of x's, right? So obviously, these two equations have those in it. Do you see what I'm saying? So I would never teach it this way. But now that we've gone through the derivation, there's a lot of hints about which equations to use. You guys, semi with me? Can anybody tell me right now, and this, by the way, just in case you just came in, nobody had this quiz. This is from a few years ago. I just want to do this with you before I give you your quiz back. Can anyone tell me exactly what the hell that means?
0.17%, 0.31%.
Of what, do what?
8 people to sleep.
17.31% of the people we talked to, what was this about?
Hours of sleep.
Hours of sleep. 17.31% of the female students we talked to got 8 hours of sleep per night, right? I love it. So when I ask this kind of question, no work to do, no formulas. You guys with me? I give you this kind of information. What percentage do sleep for exactly 9 hours?
3.85%.
3.85%. So there was a couple problems on the quiz. You just had to look at what I gave you. And I just told you the answers. No formulas to do, which I know we're not used to. You're like, well, there must be work. No, I already gave you the answer. What if I said, what percentage sleep for more than 5 hours? What percentage sleep for more than 5 hours? Well, which hours are more than 5? 6, 7, 8, 9, right? So you could add all these things up here. But what's the shortcut?
1 minus.
Yeah, so 1 minus the one that's left out, right? What do these all add up to be? Let me see if I remember this. In this case, they actually add up to be, that's right, this is the 1 year I made this, 1.0001. But they should all add up to be 1, close to it. So 1 minus this should be what the other ones add up to be, right? But if you don't do the shortcut, I don't care. You can do the long way and add these all up. You get about the same answer anyway. Okay. Right. It's like a practice from that quiz before I get that back. Yeah. Okay, so. Back over here. So 9 hours, 3.85%. Why is this a valid probability distribution? Well, I like the fact that I did this a little weird. Let's do this. Let's put all this data in the calculator. You need to borrow calculators to do that real quick. Are you Seven's ID today?
Oh, no.
I have to kick you out.
Oh.
All right. Oh, this? Yeah, I'm sorry, man. Alright, so everybody take a minute. I'm gonna clear all this shit out of here. Take a minute and put it into the calculator. I'm just gonna put the x's here. Then all the crazy ass stuff here. What's the general way to check if I'm given a probability distribution to make sure it's valid?
P of X greater than 1.
What has to be true for a given situation if I have all the probabilities?
Adds up to 1.
They have to add up to 1, right? So what's the quick way? Does anybody remember? So I need to get the sum of this list here.
Do math.
Yeah, well, do list.
List math.
So first get the hell out of here. So if everybody's got this in there, hit second mode to quit. You now would go to list, which is above stat, go to list. I want to do math on a list. I want to sum up a list. And I want to sum up specifically L2. Now real quick, what is that supposed to add up to be?
1.
1. Does this mean that it's not valid then?
No.
Why not?
Because if you did any kind of rounding.
Exactly. Some of these might have been rounded. Just like we saw back when we were making histograms. When I added up the probabilities, some of them might have been rounded up more than down, so it would have been over 1. So sum of px has to be 1 officially, but anything close to 1 is fine. So this is the way you would tell me, because I tell you right now, I'm going to do exactly this to you on the test. It could be like 0.9999 or 1.0001. I'm going to do this to you on the test. And what you have to say is this. The sum of p of x equals 1.0001, which is approximately 1. Close enough to 1. You can even just say it adds up to close enough to 1. That's beautiful. Because some people just memorize the shit they're supposed to tell me, and they don't even check. So I want you to check. So if you just say sum of p of x equals 1, I'm like, you didn't even add them. You have to add them and check. Okay. There's one more thing that has to be true, and you have to state it. You have to check it. So they all have to add up to 1, or close to 1. What's the other thing that has to be true about probabilities in general?
0.
None of them can be 0 or more than 1.
They have to be between 0 and 1, inclusive, right? None of them can be negative. You can't have a higher than 100% chance to do something, right? The whole 110% effort is a psychological thing. It's not like you're actually doing that. So, where am I? Oh, 0 less than equal to p of x less than equal to 1. You really should say for all x, but if you just say that the probabilities are between 0 and 1, golden. So you can state this in words. You don't have to state this in inequality symbols. You just have to tell me the idea. We all know this shit, by the way, don't we? We all know probabilities between 0 and 1. You just got to tell me. That's part of what makes this valid. So real quick, I just want to show you one example, because we don't see this very often. What if I had this? 1, 2, 3, 1.5, 0.1, negative 0.6. I'm not saying this is true, I'm just saying here's something somebody gave you. What do these add up to be?
1.
1. So that's all you cared about. You would think this is valid, but obviously why is this not valid?
One of them's negative,
One of them's negative and one of them's more than 100%, right? If the newscaster said there's a 150% chance of rain, what the shit does that, are the raindrops huge? What does that mean? Does it rain so much it rains in every dimension that's next? What does that mean? Yeah, okay. Okay. So this is not valid. There's a probability of x that's greater than 1, and there's a probability of x that's less than 0. Okay. What was that sound, Jeff? All right. So I'm going to ask you this part A. I'm going to ask you that. And you just have to add up the probabilities, make sure they're close to 1. So it could be 0.9998 or 1.0002. It's got to be close. And you got to make sure that they're all between 0 and 1. You got to say that. So there's two things I need for that first one. Then I'm going to ask you a question. I'm going to ask you a question. I'm just going to say, can you read this chart? So if I said the probability that slept for exactly 6 hours, it'd be 23.08%. You can just read it off of there. That's what those represent. What do I have to do to figure this out? So where's the mean?
It's L3.
This guy. And again, we're going to have a lot of formulas that have this symbol in it. So if you cover it, you tell yourself, oh, I need a bunch of these, so then I'm able to add them up. So I really just want you guys to understand. I know once we start doing a problem, it gets a little bit lost. The idea gets a little lost because you're in the details and all the shit. But if I see a formula that's got this in it, if I cover that, I need a bunch of these. Do I have a bunch of x times p of x's yet? No. So let me make them. Once I make them, I can add them up, which is what this thing wants me to do. So how do I make x times p of x? Well, I just take L1 times L2. That's where they are. So in the calculator, I can just do this. Go back to stat, edit. I can go over to L3. Make sure you got L3 highlighted, right? If you get the error that says this, you get this kind of error, data type, that means you're trying to force an entire list into one spot. Of course it's going to freak out. So you want to say L3. Now, somebody help me out. I just said it, but what am I going to make L3 equal to? X times P of X, so L1 times L2. Cool. Right? Yeah. Okay. Help my old eyes out. Okay. And then you would blah blah copy on the cracker. Right. Okay. And then how do I get? So this is X times P of X. So once I have all of them, I can add them up. And that's the freaking mean. That's beautiful, right? Just adding that one column up gives me the mean. And we went over why that makes sense. We kind of did an example as we got into chapter 4 about why that process makes sense. Okay. Now this process is a little bit lost because we did a little algebra to make the formula kind of easier to work with. But now to get the standard deviation, this is the variance. But to get a variance, I'm going to need a bunch of these. So what I normally do is L1 times L3, because x times x is x squared. You could do L1 squared times L2. Does that make x squared p of x also? Both will give you the same freaking numbers, because the math is like, I don't care what you do, human, just make it x squared p of x. So I really want that to make sense. So watch. If I go here and I do L1 times L3, which is what I normally do, I get those numbers, 3, 8, 19, 11, blah, 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 right? If I instead do L1 squared times L2, I get the exact same numbers. Because they both make x squared p of x. Okay, maybe. So this, you would copy this down into the third column. You would copy this down into the fourth column. Let me stop for a minute. Are you guys, we're right now in the nuts and bolts. And again, we went over the idea about why these formulas make sense. And we developed these formulas together. Now we're in the nuts and bolts. And again, it gets a little removed from the idea. But how are you guys doing so far? Are you following along? Yeah? No?
I'm just
Yeah. So, how do I quickly add up list 3? Because that's what I need to figure out the mean. I need to add those up.
So it's
You're
at
going to list.
Yeah. So if I go second, stat to get the list, do math, sum up, what was it, L3? And the nice thing is, I could have done this already, but if you just hit second enter, you can go back and make this L4, so you don't have to go back through all the freaking sub-menus to get to sum, right? So what does this represent? What does this represent? There's a few different answers I could take. Well, what does this mean right here?
Sum of.
Yeah, I added up the fourth list. So if you say, yeah, that's what you get when you add the fourth list numbers. I'm like, beautiful, that's kick-ass. Now be more mathematical.
X squared.
Yeah, what did this add up? This added up the x squared p of x. So this is 46.1394. That's what that is. So this is x squared p of x. So if I add them up, I'm going to get the sum of x squared p of x. And we got that to be 46.1394. Okay. So the mean is always nice. The mean is just what I get when I add these up. And we got 6.7122. Stop for a minute. The mean is beautiful because I just have to add up the xp of x, and that's just the straight up sum of that column. As almost always, the variance sucks a little bit. It's a little more work. It's not just the sum of that column, that's a part of the formula. So the formula for the variance, sum of x squared p of x minus the mean squared. So I know what this is now. That's the sum we just got. That's the 46.1394, and the mean we just got, 6.7122 squared. So I understand that, I'm not sure if you guys really follow when I say this, there's a disconnect between the idea behind something and the nuts and bolts of actually calculating it, especially for this formula, because we freaking did some algebra to it and changed what it looked like. But again, we went through the derivation of why this formula makes sense, so now it's just a matter of calculations and throwing them in the right place, right? And most of the calculations I let you use the calculator to do. I'm not testing your multiplication and addition skills. So let's see, what do you guys get when you do this?
1.0855.
Yeah, 1.08577, blah, blah, blah. Is that the standard deviation?
No.
No, why not?
It's the variance.
Yeah, it's squared, right? So the standard deviation will be the square root of this business. So I can just do square root of this business. So remember the ANS button is the last number on the screen, so I get 1.042. Now again, we did an example where we had like, do you remember the teacher that gave grades and they both gave C's and the spread kind of helped you pick which one? So in general, if I have some data given to me, I want to be able to figure out what the middle looks to be and what the spread looks to be. If I just give you those two numbers, you have a pretty good idea of how things kind of are spread out and look, right? So if I said there was one class that got an average of a 75 with a standard deviation of 5, were their grades very spread out? No. So they all got like really kind of close to 75, right? So on average, the grades got 5 away from 75. So on average, the grades went from 70 to 80. If I gave a test and it was a 75 average with a standard deviation of 20, now we're talking some people got F's, some people got A's, right? So those two numbers by themselves give me a lot of information. I don't want to look at 1,000 data points. Just give me the mean and the standard deviation. Just summarize that shit for me, right? Remember? Okay. And then this guy, okay, within one standard deviation of the mean. I don't know, I can't remember if that was on the actual quiz I gave you, but let's do this. The mean was 6.7122. If I go one standard deviation up, so one of these, I end up at 7542, I think.
Yeah.
And if I go one down, oh shit, Jeff, here we go. I end up at 5.6718. I think. So it's close enough because everything's whole numbers in the data anyway. So can somebody help me out? Help me out. Which numbers? I like to draw it like that because it's like a net. I'm throwing a net out. And what have I caught? Which numbers, which data points did I catch in here? 6 and 7. Because 8's over there, 5's down here. So I caught all the 6s and the 7s. So what's the total percentage then? Yeah, that 6346, I think.
Yeah, 60%.
So 63.46% is within one standard deviation of the mean. Okay. Crazy shit. Now, just to let you know, I think I said when we got into chapter 6, so this is kind of like building up the chapter 6 idea. Because later we can, if this is normal, I can make z-scores, I can count the percentage between. Okay. Number 2, what kind of probability problem is number 2? So read through that real quick. By the way, the percentage might be different now because this is like from 2016 or something. So what am I asking people? If I take a sample, what am I asking them?
Are they vegetarian?
Are you a vegetarian? What kind of answers can they give me?
Yes, no.
There you go. If they say, well, every other Thursday, no, yeah, you're not a vegetarian, right? So it's got to be yes or no. 2 possible outcomes. So what kind of distribution is this? Binomial. By 2 possible outcomes. What's the probability of success? In this case, vegetarian is a success. 5.3%. So what can I start to do for myself? This is what I call an NPQ problem. What's N?
41.
Yeah, N is always the size of this thing, the group I'm looking at. So I'm looking at 41 people. P is the probability of success. You got to write it as a decimal. And Q is the rest.
947.
Say again?
947.
947, exactly. You got to make that equal 1, P and Q together. Let me stop for a minute. So, on these kind of problems, you have to just stop and kind of identify what situation you're in. The x p of x table is easy. I'm going to use the formulas that have x and p of x in it. This one, it's pretty much going to have the same feel. I'm going to give you a percentage of stuff that do things, right? Just to be general. It could be a percentage of dogs that, wag their tail when they see you. Whatever it is. I'm going to give you a number of things we're looking at, and then I'm going to ask you a question. Well, what's probably we get this many? Okay, that's a binomial probability situation. Now I want to know what N, P, and Q are. So then the formula is this dude, because that's the probability that has N, P, and Q in it. So I got 41 Americans. I want to choose how many? 3 of them. So that means I have 3 of those, and the rest are failures. 3 successes, and the rest are failures. So I think a few of you guys set up the formula correctly, but something went wrong when you tried to put it in the calculator. So 41, oops, let me keep that up there. You go to math, probability, choose 3 times 0.053 to the third times 0.947 to the 38. And how do you kinda check this is on the right track? What do these two exponents have to always add up to be?
The sum of what you're looking
The total, because you're taking any group and you're breaking them into two subgroups. So it's roughly a 20% chance. You just dump down to this one. And then these guys are just these formulas. I think a decent number of you guys got these right. You just have to take n times p. And the standard deviation is going to be n times p times q, square rooted. 41 times 0.053. So I get 2.173, and if I do the square root of np times q, I get 1.435. Now, what's the idea behind max and min? How far out do you go to hit the, where usual is?
for.
2 steps. So if you think about it, if I had the mean height, and I took the standard deviation and went 2 steps away from that mean height, that should capture a good chunk of people. So anybody outside of that would have an unusual height, an unexpected height. So I would just take the mean minus 1.435, 2 of those, check, not the 2 there. And I would take the mean plus 2, 1.435. So that would be roughly, let's see, where did I put this? Let me put this down here. So this would be 2.8 roughly, so that'll be, this actually comes up to be negative 0.7 or so, up to 2.8, so 4.9, almost 5. So would it have been usual to get 7?
No.
Is 7 in the expected area?
Wait, yes.
7's out here. So yes, it would be unusual to get 7, because it's outside of 2 standard deviations. So I always like to think about, that's why I like this example of the nuclear reactor. If you think about that little meter that goes from green to yellow to red, the red means you're starting to get into really unusual territory. You're out here. Yellow means you're getting close. Green means you're in there, so you don't have to get up. The minute it starts going toward yellow, I'm like, shit, we're starting to get really far away from where we should be. So, okay, give you back your quizzes. I did curve them a little bit. Yeah. Okay, here's a copy, so you can see what it looks like. Basically the same as that one. Let me see if I get the right tie. This one. Twice. Oh. It's here. And Sophia Mundo, I did basically the same as that one we just did, but there's a copy of what that looked like.
Oh, you're giving me back my copy? Wait. That's very
Yeah, that would be neat. You didn't take it, right?
No,
Oh,
I
that
didn't
would-
take it.
That would be neat. So, take a look at your quiz. I'll give you a couple minutes to look at it, and then we'll sort of open the, well, I'll give you a couple minutes to look at it. We'll create the formula sheet you can use for the test, and then I'll open it up to whatever questions you guys have. I have the answer key for the practice test, so don't head out before you get that.
Was class ending early today?
Huh?
Is class ending early today?
I don't know. depends. If we're just sitting here staring at each other, nobody's got questions, we might head out, but I want to make sure I get all the questions answered.
Are we gonna go over how to do the practice test, or are you just gonna go answer key?
No, yeah, totally, no.
Okay.
Yeah, we can ask, you guys can ask any questions from the practice test, from the quiz, from the earlier quiz, anything, from homework, yeah. Towards the end of class, I'll give you guys the answer key.
Oh.
Yeah. And don't forget this, there were quite a few kind of low grades on this quiz, but the nice thing is, if you make corrections to the quiz, and then you do better on the test, the quiz grade can go up twice, right? So the more corrections you get right when you do the quiz, and you get a higher test with the grade, the quiz can go up higher depending on how many corrections you get right. Does that make sense? If you get all the corrections right, and you make a higher score on the test, the quiz grade becomes the test grade. Holy shit. Do you understand what I'm saying? So I'm a big believer in grades not being static. They should be dynamic as you learn more. I'm sorry, somebody have a, yeah, what's up? Yeah, okay. Oh, so these are way bigger than one, so I think, here's the problem. You have your calculator with you? Oh, okay. So the trick is, you don't want to do it piece by piece, because these, I'll bet you anything, much as 0.16 to the 7. It isn't 2.684, it's times 10 to the negative 6. So, here's the way to do this. If you don't do it piece by piece, so put that whole thing in. So go ahead, do 62, and then go to choose, so that, probability, go to choose. So this is one thing you didn't realize, you don't have to do that. Oh, went the wrong thing. Choose 7. Now hit the over arrow to get back up. Hit the over arrow, yeah. Now keep going. Times 0.16. And just keep going. To the 7th power. Hit the over arrow to get back down. Times, yeah. You just put it all in there at once. So the really big part and the really small part kind of average out. There you go. There you go. Sure. All right. So now you've got the sheet we just went over and the original worksheet we did to kind of go and help you with the quiz corrections, right? I highly recommend that when you do corrections, you get help from a tutor, you get help from me. Here's something you could do. Hey Jeff, I got the corrections. I'm not turning them in. Can you tell me if they look okay? And I will tell you, this one's good, this one no, this one's good, this one's no, this one's no. You guys follow? So the worst thing in the world is to do all these corrections, turn them in, and you get no points back because they're all still wrong. That's just wasted effort, right? So please use a tutor, use me, double check your answers on your corrections so you get the most points back that you can. Test 1 corrections are a little bit more of a priority because tests are heavier weighted. So if you can raise the grade of your test 1, that will affect your overall average more. So I'd say your priorities are this: homework, test 1 corrections, quiz corrections, practice test, right? That's what I would do if I were you. Kind of with me? And of course, you don't have to do that order, but that's what makes sense to me. So anything from the quiz? Okay, so let's do this. Let's create what your formula sheet, whenever we do this formula sheet, obviously if you lost points on the first formula sheet because you had too much information, rewrite that shit. But whenever you make a new formula sheet, you can add it to your old formula sheet, or you can make a brand new formula sheet. So on the final, you can bring all these formula sheets with you, right? Does that make sense? You're just going to keep turning them in as you do a test. So the things to add for this test. So remember chapter 3 had its own little mini double quiz, whatever, mini test. It's not going to be on this test, chapter 3. Probability from chapter 3 won't be on this test. Start at chapter 4. And chapter 4 was the XP of X stuff. So it's all these formulas that are up there. These two are from 4.1.4.2. And then section 4.3 was the binomial business, right? So you can do this on your formula sheet if you want to. You just can't don't write next to it. Probably just, you can't write words. And then the next few things are going to go together. All of these are related to NPQ problems, binomial distribution problems. So if I were you, this is what I would do, kind of group them together so that if I identify a situation, I know what little chunk to look at. So that's chapter 4. Chapter 5 was uniform distribution, and to be honest, I told you guys, I'm not going to put the mean, the a plus b over 2 and the square root of b minus a squared over 12, that thing, I'm not going to put that on the test. So don't even write it on your formula sheet. There was a problem on the practice test that you had to do that for, but I'm not going to put it on the actual test. So don't even write those. So there's no formulas for chapter 5. Do you guys know how to draw a uniform distribution? I think we all by this time should, right? It's just a big ass rectangle. Yes? So chapter 5, no formulas. Chapter 6, some formulas. So you've got this guy, you've got this guy. All right, so that's an idea.
Real quick, for the NPQ, can I put like parentheses around P and Q so I remember to put in the calculator?
Oh, like this?
No, like for like, well, I guess yeah.
To make sure it's all in a square root?
Yeah.
Sure.
Okay.
If you want to, yeah. And then chapter 7 is where we did basically this work, but we did this. So I had to change the standard deviation before I did this. Let me think. I think that's everything. If anybody has suggestions on more formulas you want to put up here, let me know now, because otherwise this will be it. Does anyone think I missed any formulas? And I'm just a human, and I could very easily have forgotten something. When do you do this, by the way? When do you have to do this? Here's the funny thing. Again, a lot of formulas are notes. You're not allowed to have notes, because I'm a jerk, right? You're not allowed to have notes. But formulas are notes. What does n mean? What's n mean? The number of what? In the sample. Okay, n is always the size of the group I'm looking at, you guys, the sample size. So n is, so when do I have to do, and then x bar, what's x bar? What's X bar?
Sample,
Sample mean. There you go. X bar is the sample. So when do I have to do this? When I take a sample and I ask about the sample mean. So the formulas kind of, some of them, tell you when they should be used. Right? So I'm a little concerned that there are certain problems in the homework that I've only had one person ask me about, because there are some weird problems in chapter 6 and 7. They are a little weird. But, you know, it's up to you if you want to ask questions or not about that. It's up to you. Anything else? I'm open to suggestions, right? Anything else you want to put up here? Like one time I asked my tutors, do you guys need anything? And the one guy said, I need a PlayStation 5. And I'm like, request denied. But, you know, I have to ask. You never know. Okay, does that look good? Okay. So again, just remind you guys, if you have good formula sheets from before, you can just add these to it, or you can have this on a separate one, right? Let me really think. I don't think I missed anything, no. Nope, that's everything, okay. So, let's talk about the practice test. One big thing I want to remind you guys about. I will bring some clean z-score charts, because remember, you can't have any notes on your z-score chart. When you do the test, you're going to turn your formula sheet and your z-score chart in with the test. Just so I can make sure, or at least show it to me. I'm going to ask you to show it to me, and then you can keep it. Yeah. So make sure it's clean. If you've written notes on it, then I'll just give you a clean copy for the test. You guys with me? You can't have extra notes hanging around on anything. Let's do this. We've already done one like this today. Right? In fact, was it exactly this one? No. Oh, it was different. Okay. Let's try to do number 2 real quick together. If you've already done this, just kind of hang out for a bit. So for number 2, you're going to need your z-score charts, right? Now, please, dear God, if you have a specific question, that takes priority. But I'm just going to make you do some stuff if nobody's asking me questions. Did I bring my own z-score chart? I don't know. Here we go. All right, let's see real quick. Let me catch up to you guys. So I'm not going to take points off if you don't draw a picture. But what I am going to do is if you make a mistake, you're going to lose just about all the points because I'm not going to know what happened. So I highly recommend you draw a picture, but you don't have to. So for number 2, what number is going to go right in the middle? 0. Cool. For z-scores, when you make a mean into a z-score, it becomes 0. Whatever it used to be, it is 0 now, because it's the distance from the mean in standard deviation. Negative 0.52, of course, goes down here. And I want the area to the left, which is awesome because that's exactly what this chart does, right? I just look up, what'd you guys get when you look up negative 0.52?
2.3015.
0.3015? Yeah. So this area is 0.3015, kabam. Why didn't I have to do 1 minus in this problem?
What was that?
Why didn't I have to do 1 minus something?
Because this always tells you what's on the left.
Yeah, so the table always tells me the area below, and the question wanted the area. So of course, I don't have to do anything. I don't have to adjust anything. Part B is gonna want to the right, so that's one where I gotta adjust it. So if I put negative 3.16, I want to the right of it. So when you look up negative 3.16, what'd you guys get?
3.16 is
Zero,
0.0008.
0008. So then this is gonna be
9992.
1 minus that 0.9992. I love it. Okay, so, in part C, well, we'll talk about it in a minute, but please, your God, these are gonna be on the test. So when I tell you I have a standard normal curve, that's all z-scores. You don't have to use a z-score formula because they're already z-scores. You just have to look up the areas, right? What's gonna happen in part C? I want the area between two z-scores. So then I have to look up both of them. And then of course this makes good physical sense. I gotta subtract those two because one of them is too big. Subtract out the other dude, I get the area in the middle. So has everybody got their z-score charts out? Can somebody else, Nico, can you tell me? When you look up 1.98 on the z-score chart, what do you get?
Point 9699.
Let's see. 969. Yes, cool. So 9699. And then, whoa, wait a minute. What is it? 1.98. Careful. Yeah.
Mm.
My eyeballs are not good. So 1.98. So it should be there.
Oh, my bad.
Don't worry. It's easy to do that. 9761. So real quick, for that kind of mistake, I would take off a point or something. It's not that big of a mistake. It's really easy for your eyeballs to kind of go, trust me.
There's so many numbers.
I know. Shit ton of numbers. So what about 0.14?
Oh, 0.14?
Yeah.
Let's see. Oh, 0.14?
Yep.
So it's like the same thing? Does it have a 0 on it? Or,
Yeah, 0.1. Yeah.
A 0.1?
4.
Oh. 5557.
I love it. So of course, to get the area in the middle there, you just subtract those two. Right? So, all right. So this is a beautiful example of the nuts and bolts of doing something is removed from the idea of that thing. When we have like a uniform distribution, what's really nice about a uniform distribution is you can actually calculate, you can see, you can kind of get the feel if I wanted to, from 3 to 5, I just got the area of the rectangle. And that means if I'm waiting, well, what's probably a wait between 3 and 5 minutes, it'll be 2 times the height, 1/6. This one is a little removed because we can't do the areas directly. What's up?
I have a question about that.
Yeah.
Is there ever a difference where it's like exclusive or inclusive of the 3 and the 5?
Ooh, beautiful. I love it. Okay. It's a great question. So if I said, now let me ask you this. So this is part A, let's say. Part B would say, what's the probability X is greater than 5, right?
Yeah.
So greater than 5 means from 5 to 8.
Just three.
This is 3, so it'd be 3 times 1/6, 1/2. What's probably x is greater than or equal to 5? Same thing. Because again-
Infinitely thin.
Yes, infinitely thin. So it doesn't add anything, or it adds such a small amount to the area that it doesn't show up. Yes, okay. Beautiful question. Any continuous distribution, an individual number has equivalent to a 0% chance of happening. So if I include it or not, it's not going to change the answer. This will still be 1/2. Cool. I like it. I like it. Somehow that might relate to a bonus question. I don't know. So for this problem, number 5, it's a lot like the one we just did, number 2, except these aren't z-scores yet, right? So try to do, I love this is like a legal document. Try to do number 5, subsection A, part 1. Heretofore known as the party of the first part. So number 1 there, try to do that. Yeah. Draw that picture, what's going to go right in the middle?
0.
No. Oh,
281.2.
sorry, so how should I know?
0 z-scores.
Yeah, so, yeah, when I tell you have a standard normal, then you know whatever the mean was, we don't even know, we just put a 0, because all we know are z-scores. Here I know the mean is 281.2. So 302, of course, is going to go up here somewhere. So I want this area here.
So
So I-
302 minus.
Yeah, I want this process to become sort of just a kind of a recipe, right? Make a z-score out of that number. So x minus the mean divided by the standard deviation.
0.60.
0.60?
Yeah.
And then, of course, this is a situation, see, I was nice to myself, I shaded in the area, so I know when I look it up, that's not the answer.
Yeah.
And again, if you wanna do the shortcut, I'm not gonna do it again, but if you remember it, you could do it, you save like 1.8 seconds, so. Woo-hoo. But still, you know, it's just short.
2743.
For the answer,
Yeah.
so you get 0.7257.
7257 is to the left.
Yeah, so this is 7257,
And to the
so
right
then
is
1 minus that,
2743.
yeah. So I want that kind of problem just by itself to be just a recipe. It's beautiful. I give you X score, you make it into a Z score, because then I know I got this chart with all the freaking answers if I just know the Z score, right, for a normal distribution. So number 2, number 3, they're both the same. I just make those into Z scores. Number 2 is gonna be that like the last one we just did earlier. I gotta look up both z-scores, get the areas, subtract the areas, right? But I just have to make both of those into z-scores. Number 3 real quick, I think, yeah, let's do number 3, because that's related to a question that came up earlier. If I want less than 100, You guys agree with me, that's pretty far away from the mean, right? Yeah, especially because every step is just 34.48. So put the mean in the middle, I got 100 down there, I want less than 100, so I want this little tiny area here. Take a minute, don't say anything. Can you please change 100 into a z-score? Don't say anything. You can ask a question, but don't tell me the answer. Don't tell me.
Also, oh no, I was gonna ask something.
Yeah, what's up?
I think it was, do we divide, wait, do we do like 100 minus 281?
Good, divided by?
Divided by, 34.
Kick-ass. There you go, that's how you always make like an X score into a Z score. X minus the mean divided by the standard deviation, so this will be 100 minus 281.2 divided by 34.48. 5.26. Negative, right?
Yeah.
How far does your chart go? If you try to look up negative 5.26 on your chart, can you?
Not there.
It's not there, damn it. So you could either use this 0.001 that they give it, 0.001. I really think about it. If you go 3 steps down, that's pretty far down. There's very little. If you go 4 steps down, oh holy shit. You go 5 stupid steps down, there's basically nothing there. So I would either accept 0.0001, because that's what the chart says, but do you understand how that's not true? If I keep going further and further down, I'm going to keep getting less and less area down there. Yes?
Yeah.
So I would accept either 0.0001, because that's what the chart says, or approximately 0%. Either one of these answers is fine, because I am 5.26 steps down from the mean. I'm in some crazy unusual territory. There's so little shit down there, I'm going to say it's about 0, right? It's about 0% chance. So if I ask you what's probably somebody ends up being 9 foot tall, based on our experience, I can't say 0 exactly, can I? But I'm going to say it's about 0%. It's the next thing to 0%. I don't know why I'm going to say it like that, but I just will. All right. You guys understand that? So anytime the z-score is off the chart, I would accept 0, approximately 0, or approximately 100%. Right? If I would have said greater than 100, I would have accepted about 100%. So if it's off the chart, it's going to be extreme. Almost 0 or almost 100. Let me ask you this question. The very first problem we did. Can somebody explain to me what the hell that means?
There's a 27.43% chance that the score is at the, wait, what is the context?
I understand. I feel the same way.
The context, whatever, it's about 3.
The trash. So there's 27.43% chance that a household generates more than 302 pounds of trash. Holy crap. Right? Okay. Another way to say that is 27.43% of houses generate more than 302 pounds of trash, right? Because probability and percentages really are the same thing. So if I said there's 120 houses, how many would be expected to generate a mean weight? Well, what percentage of them? 27.43% of 120. So you just do that. By the way, did I do? Okay, I used the right number. Yeah. Back in my brain. So it'd be, I expect 27.43% of all the houses to be generating that much trash. So specifically of 120. So then I just take 2743 times 120 because of means times. And that's something that I've noticed people coming out of high school nowadays, they know less and less what of means in math. It used to be, of course, of means times, but now it's like, I don't know. It's not your fault. It's just, I don't know what they're doing. So then whatever the hell that is.
32.916.
So I would round it up to 33 houses, right? About 33 houses. Okay, maybe. So, a real quick real world example, if you were selling tickets to some event, and you sell more tickets than there are chairs, why would you do that? Same thing as the airline, right?
You don't expect everyone to show up.
Don't expect everyone to show up. Wouldn't I like to know the probability of more people showing up than I have chairs?
Yeah.
Because then I can translate that into a number of people, and then I know how many people could be angry, right? I could kind of get ready with a message I want to give them, or with like compensation or something. You with me? Standing room only, but we'll give you a free drink, something. You guys with me? So you kind of know ahead of time, worst case scenario, how much money am I going to lose by giving people something because I didn't give them a seat, right? You guys with me? So it's just the same thing with airlines. They do the same calculation because they know if they are going to ask people to voluntarily not board the plane, they have to give them some kind of compensation. And if you go often enough to fly, you will hear over the loudspeakers, well, anybody give up a seat, we'll give you $200 vouchers for blah, 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 or something, right? And then about 5 minutes later, we'll make it $300. 5 minutes later, and you're just sitting there waiting. When they hit 500, then, you know, so, again, I don't know why all my people are Southern, but, yes.
That reminds me, like, I've done Collins work early, and I'm like, yeah, sorry, I can't come. They're like, we'll give you $50. And I was like, make it 100 on coming. And they said, no.
Yeah,
I was like,
yes.
'cause
So
it was
the
like,
better they know their math, the more they know how much would actually
they
make
know-
it, make
they're
it
gonna know
hurt.
how much they're
Yeah.
gonna lose if no one
Yeah,
shows up.
yeah. What's the dollar amount where you're like, no, just don't come in?
It was,
I'm with you.
it's because they called me at like 6 in the morning.
Holy shit. That's how I work.
That's probably like one of those guys that does, what's it called? That like just randomly call you and they ask you, they wanna buy this and that.
No, not usually.
Okay, good. All right, guys, so let me do this. Just to remind you, so I'm gonna give you the answer key for the practice test. The absolute worst thing you can do is to just sit there and go, uh-huh, yep. Yep. So if you haven't tried the practice test, don't even look at this answer key. It's just gonna build up false confidence, because it's easy to agree with me. But if you have tried some of these, I want you to have this. You can double check me, let me know if I made a mistake. I'm averaging about a 97 on these answer keys.
Thank you.
I have a question.
Yeah.
Do you have an answer key for the test, or the quiz?
For the, what do you mean? Sorry.
An
Oh, for the
answer-
quiz, that was.
Yeah.
So what you can do if you want to is, you can try those problems out and I'll let you know if they're right or wrong.
I did.
But the problem is I don't wanna give the answer key out in the wild because that'll help people with their corrections if it gets out. Oh, you did? Okay, shocking.
Can you do 5C?
Huh?
5C, just.
5C. Okay,
I
we'll
I
do
don't
that
really
one.
know how to.
I didn't show like anywhere, and this one I didn't do because I didn't calculate it.
Let's see. Do. Yeah, this is one. I see. Okay. Yeah, you gotta go. I would like to see these set up, and then you check the work in the calculator. And then this, you weren't sure how to put it in. Is that what happened?
No, because I was just using phone calculator. I didn't.
Oh, got you. Okay.
So
Got you.
I just set it up.
Okay, good. I like it. Yeah, everything looks good. Thanks. So was it 5C?
Yeah.
Oh, okay. So I know I want to be in the top 5%. So, these problems up here, real quick. These 3 problems. Isn't it basically I give you X's, you make them into Z-scores, and then you look up the percentage?
Mm-hmm.
This problem, I gave you the percentage, so you're gonna basically do all this in reverse. I gave you a percentage, where's the top 5% in the picture?
To the right.
Yeah, it's gotta be up here. And now I wanna be able to look up that Z-score. Now what's wrong with looking up 0.05? I don't wanna look up 0.05. The Z-score chart's not gonna know what to do with that.
You wanna look up .05 that has Like that has 0.05.
No. So the z-score chart only understands areas that are where?
Uh,
Below or above the z-score?
Below.
Below. So if there's 5% there, what percentage is below it? If there's 5% above it,
95.
95. So that's what I looked up in the z-score chart, it's 0.95. And this should be one of the little asterisk dudes. So if you try to look up 0.95, you see how it's right between those two? So if you just follow the little asterisk dude, they just split the difference, 1.645. So this is 1.64, that's 1.65, so right in the middle is 1.645. So watch this. Look at this problem here, this very first problem here that we did up here. Wasn't the very first thing we did, we took the x and we made it into a z-score. So this is using the formula. And then we looked up in the chart. Okay. So didn't we just do all this in reverse? We looked up 0.95, we had the percentage, we looked up in the chart to get the z-score. Now I want to use the formula to change it back to an x-score, but one backwards. So I don't want this formula. I want the backwards formula. Right? This is if I have an x and I want to make it a z. This is if I have a z and I want to make it an x. These two are mathematically the same formula. So the next will be the mean. Where'd it go? The mean plus 1.645 standard deviations. Past Jeff do that correctly. Let's see. Past Jeff, yeah. Okay. I can't remember if I had my little homework talk with you guys about making homework your own. So if the test is coming and you're kind of behind, the worst thing in the world is to take the test and never have looked at problems in certain sections. So the closer the test gets, the less you worry about doing every single problem I assigned. You do some out of every section, just to give yourself practice across all the kind of problems. Because I always get somebody who turns the test in and they say, man, I couldn't do those last two because I never did those sections. I'm like, what the hell sense does that make? I have questions I want you to do. You say, that's great, Jeff. I got this much time. Right? I got a lot of shit going on. Because that's what I did in college and grad school. I didn't finish all the homework. I did as much as I could because I was working 3 jobs, walking uphill both with, no, working 3 jobs is true. So I didn't have all the time in the freaking world to do every homework. I just didn't. It was physically impossible. So I did as much as I could, and I skipped some so that I had enough practice to kick ass on the test, right? So please don't just not do homework because you're like, I'm never going to finish that, so I'm not going to do it. No, it doesn't make any damn sense. Do some. Turn it in. You know, I'm going to be like, oh, finish this. And you're going to say, dude, I'm doing as much as I can. Right? So there's that play between what I think you should do versus what you can do. So you got to make education your own thing, right? Okay, maybe. That doesn't mean I'm going to be like, oh, it's fine. No, I'm still going to do my job. But you do what you can to get ready for the test. And again, some of these homework problems are a little weird. They just are. It's a free book, and sometimes the way they word things are a little bit strange. I totally get that, right? But it sucks when that's true when you paid $180 for the book and they're like, you can't even construct a sentence. Good job. At least this one's free. So yeah, definitely get help if something doesn't make sense in the homework. Okay. So is there anything on the key that looks like it might be wrong, or I don't know how many guys have had a chance to even try the practice test yet, because homework takes a little precedence to it, but, what would happen down here? Do you see how it's almost the same question as up here?
Yeah.
What's the big difference for part D?
New standard
Took a
deviation.
sample, so what's 33? What's the variable for that?
The sample,
What letter do I use for it?
N,
N, good. So I have a sample size. And what's the question asking about?
if we select 33 or sample.
Sample me. So the two triggers, if I take a sample and I ask a question about the sample mean, that is when this dude happens, right? Take a sample, ask a question about the sample mean. So the very first problem on this little number 5, did I have to do any of that shit? No, I took one house. I didn't take a sample of houses, I just picked a house from the population. Okay, so I used the standard deviation they gave me, because that standard deviation, 34.48, is how spread out individual houses are from each other. This one, I need to know how spread out 33 groups of 33 houses are from each other. So I can't use 34.48. I have to construct the correct standard deviation. I have to make the right spread. I don't want the one that works for individuals. I don't want it. I want the one that works for groups. So the very first thing you do on this problem is change the standard deviation. It was 34.48, now I gotta divide that by the square root of 33. And then the funny thing is, the minute you do that, you do all the same frickin' work you did for part A, except you're gonna use the new standard deviation to make a z-score. So chapter 7, the idea was freaky as shit. We talked about alternate universe Florida. We did the weird thing with all the colors where I picked numbers out of a hat. The idea is weird as hell, but the freaking work that it adds is minimal. This is the one thing it made you do. Don't use this, change it, now do all the same. Make a z-score, right? So now instead of doing the z-score of 302 minus 281.2 divided by 34.48, I'm gonna do 302 minus 281.2 divided by whatever the hell this is, which I think is 6.002, is that right? Did we do that?
Yeah.
Is this 6.002? Is my memory right?
Yeah, 6.0.
Sounds about right, okay.
Yeah.
Do you see how it's almost the same freaking work, right? Except the number changed, that's all. And then once you get the z-score, you look it up, you get the area. Okay. So again, the whole idea, like the very first problem here, that's gotta be like a bread and butter thing. That's an old saying, but I don't care. That's gotta be like your wheelhouse. It's gotta be like, oh yeah, give me a bunch of those freaking things. I can make a z-score, I can look it up, no problem. And then this kind of problem just adds one step to that process, right? Just this one step. And again, the idea is, if I take one person and they're 6'5", I'm not gonna freak out. If I go take a random sample of 80 and their average height is 6'5", I'm gonna freak out. What the shit, right? Because if I take a group of 80 people, their average height should be close to the actual average height. Any group I take, their average should be close to the actual average. And that's why the standard deviation gets freaking smaller. The whole thing comes closer to the middle, so it's less likely to be way the hell out here. Maybe.
Question so like,
Oh, yeah.
Like, but what if it was the sense in reverse? How
If it was greater than 22,
Yeah.
then I would just take 23, 24 and add and be done.
Oh,
Because
okay.
the only things greater than 22 in that problem are 23, 24.
So if it was reversed, you see 22 plus 24. Like,
23 plus 24, yeah.
Okay.
Does that make sense?
Yeah, no.
So the reason I did what it is because less than 22 is 0, 1, 2, 3, and I have to do a formula for all of those up to freaking 21. I'm like,
Okay.
screw that. The opposite is 22, 23, 24. Cool. Much less work, right?
Would you see this sign more than the opposite sign in the real test?
Well, if same thing as if I said like, what if I said x greater than 1 here? What's greater than 1? 2, 3,
Yeah.
4, 5, 6. Okay, I'm not going to do that shit. What's the opposite of greater than 1? 1 or 0. I'm going to do 1 or 0, add them and subtract it from 1. I always do the opposite probability if that is less work. That makes sense. I don't want to do all that freaking work. Okay. I like it. I like it a lot. There we go. Okay. You guys know, in case you're interested, there's a transfer fair, I think, happening today out in the quad. You guys heard about that? If you're thinking about looking into transferring somewhere, there's a transfer fair out there. And to be really honest, I'm not exactly sure what it is. I think probably there would be representatives from colleges there, but don't quote me on that. But they should have information about transferring, right? So you can run by there if you want to. There might be food, don't quote me on that either. Sometimes they have food, sometimes they don't. Huh?
Definitely not gonna be good.
There won't be food? Oh, sorry. Sometimes they have food out there in the quad. And there's a long line, I'm like, no, it's okay.
Actually, now you mentioned it, I remember one time there was like a job fair and they had like cookies.
That's food.
That is food.
So again, you're not alone with this stuff, right? You got a lot of people that can help. Sometimes, if you don't understand something, you have no idea how far you are from understanding it. So most often when I have somebody come and ask me a question, they're like this far away from understanding something. They have one little thing they didn't realize, but you feel like you're this far away from understanding it because you don't understand it. You don't have a clue how far away you are. So even if you mostly feel good about something, you should go get help. You should go double check something with somebody. So there's tutors, there's me. Has anybody ever looked on YouTube? Not even at my channel. You're like, God, I listen to this guy talking up. So have you looked on YouTube? Like you can just go to YouTube and search standard deviation and see if there's any videos people have posted about standard deviation. And you're like, I like this person, so you can look at their channel, right? So that's something. Just to be an old man for a minute. Something I couldn't do back in my day because we didn't have the internets until I was in college. That's when the internet came out. I'm like, oh my God, dude. My mom listened to 8-track tapes. Yeah. Okay, sorry. I'll stop. Bless you.
Thank you.
Bless you. Real quick, this is going to become sort of important in one of the chapters after the test here. look at this question here. Find the z-scores bounding the middle 91%. What the shit does that mean? So if I draw a normal curve, right, I got a normal distribution, I want the middle 91%.
I was gonna say, so you have that and find the z-scores that find the, what is that, 46 and a half, or, no?
Yeah, so real quick, let me get I know where you're going. Does everybody agree that's the middle 91%, that picture I just drew? I can't use the chart for that, because the chart only understands areas that are below something. So I want this z-score and that z-score. If there's 91% in here, how much is out there?
0.9 or 09.
0.09, so how much is over there?
0.45.
0.045. So then you can look up 0.045 and you can find the z-score. Now, what do you think this z-score, how do you think these two are going to compare to each other?
They're gonna total up.
Huh?
Total up.
No. Whatever one is, the other one is the opposite sign. They're symmetric, right? They're symmetric around 0. I bounded the middle 91%. So when you look up 0.045, what do you guys get? What is easy? You look up 0.045, that's an area, right? So it's going to be in the middle of the chart.
That makes sense.
It's positive, correct?
Well, 0.045, in fact, is this z-score positive or negative, this one?
Oh, negative.
Yes, good. Negative 0.045, the closest I can get, looks to be about here maybe. Let's see over here. 0.045, good lord. If I could just see. 0.04, here we go. So I can either do 0.044, what does that say, 8? Versus 0.055. No, I don't believe so. This one's closer. So it looks to be negative 1.70. So then I bet you anything it's going to be positive 1.70. Because it's symmetric. And real quick, if you wanted to look that up, what area, so there's 0.045 below this one. What's below this one?
1 minus,
No.
wait, no, yeah. That
So what's below this one? 91% plus
Yeah.
4.5%.
955.
So 0.955. So if we look up 0.955, I'll bet you you're gonna get 1.7. So it's symmetric. And once I get one, the other one is just the opposite sign.
And that's the equation, that's it.
That's the idea, yeah. So I asked for the z-scores, and did we get them? Yep.
And that's
Those are the two z-scores that have 91% between them.
That's a lot easier than what I would have
Good thing I talked about it.
done. So I was gonna do like cut it.
Oh, I see what you're gonna do, I think, but yeah, don't do it, yeah, no.
Do you also need to find the z-score for 91% too, like you did?
Yeah, see, that one's easier because that 91% is below it, so I can just look up 0.91 and just get
Okay.
it. So those two questions are fundamentally different. This one's below, so I can just look that one up directly. That one's in the middle, and the chart doesn't have a clue about freaking areas in the middle. Right? And you're like, I don't know either, but that I have to take the question they give me and change it into an area below something, because that's what the chart understands. So that is the area below this dude. That's why I'm able to look him up. The 0.91. If I look up 0.91, I'm not going to get anything related to this question. Because 0.91 is not an area below something. It's an area between two things. Okay, maybe. So I will say this, if you're, if at any point you don't have any more questions, you definitely don't have to hang out here. Some of you guys are looking at me like, if you have more questions, stay and ask. Yeah.
I was just gonna say, like, whenever you have the uniform probability, I think I understand it, but it's unintuitive how it's like, you have uniform probability and it's bound by like 5 and 10, you have an equal probability of having exactly 7 as you do having 2.
Yes,
It's out of the range.
yes,
It's weird. I don't like that.
I know. It's just because of and that's why it's not really equal.
Yeah.
I mean, honestly, one of them is 0,
And one of them is infinitely small but not 0.
which is called iota.
Yeah.
So if you look up IOTA, it's the idea of the smallest positive number, right? So it's not 0.
Is there a variable for that or no?
Yes. Shoot, let me see. It's just the Greek letter iota. And I put all the Greek letters up on Canvas, yeah, but I can't remember now. I think it's like this, but I'm probably wrong.
Let's see.
I'm probably wrong, but yeah. We don't really use the symbol too much, unfortunately, but the idea is pretty straightforward. Yeah.
Use all you have. 1, 4, 5.
Oh, okay, real quick. If there's 91% in the middle, what percentage is outside? So if there's like 91% of the people in the room, what percent are outside the room? If there's a 91% chance of rain today, what's the chance that it won't rain? All right, listen. If you got 100 people, and 91 of them like Game of Thrones, how many of them don't like Game of Thrones? You got 100 people, 91 like it, how many don't like it? 100 people, 91 people don't like it. I'm sorry, like Game of Thrones. How many don't like Game of Thrones? 9, right? That leaves 9. So if there's 91% in here, what percentage is left over to be out there? 9%. Does that make sense? So if there's 91% inside, there must be 9% outside to account for everything. The whole picture is 100%. 91% in, 9% out. So how much is just on that side? Cut this in half, right? 9% outside, 4.5% on one side. So if there's 4.5% there, 4.5% there, 91% there, that's 100%. That's everybody. Maybe. So if I would have said 80, that would have been 20 outside, 10 on one side. That would have been 0.10. Yeah. So a lot of what we do is based on the fact that the whole thing is 100%, right? That's why if I know one chunk, I could do 1 minus the other side, right? Okay.
4C. Like that's one 0.
Yes.
Because,
Oh, why is this answer 0.05? Because that's the
oh,
area of that rectangle, right?
yeah.
So if I draw a 5, put a 5, the area of the line
And 0
from
because
5
there's
to
nothing.
5 has got a 0 width.
Okay, because there's nothing
yeah.
between it. Okay, got it.
Again, like Edmundo said, for us, we're just saying 0.
Okay, got
In reality, it's the next thing close to 0, but we just say it's 0. That's pretty much 0 for most people.
This is iota. Capital, it's just capital I.
Oh, okay.
And the lowercase 1 is.
Oh,
Lowercase
because
1
I
is-
was confusing it with, like, there's, that is phi, or phi. This symbol is, if you look up PHI.
Oh, yeah.
So I didn't think it could be that, but that's cool. So it is basically a big old I.
Capital I and the lowercase.
What's the
is
lowercase
just
look like?
Lowercase is like a curvy L.
Curvy, okay. Like an I without a dot.
It's like a lowercase t without the dash.
Okay. What is that one, the one I used? Is that Ada? Look up ETA. Yeah, that's the one. Okay. That's, I mixed it with Ada. Okay. It's like an N with a little bit of a
Couldn't tell you.
fancy leg end.
So for 4E, Is this when we finally do like a normal distribution?
Yeah, so now I'm taking a sample, so I can take this standard deviation and change it. And then it's normal, so now I can do z-scores.
Oh, okay, cool.
Normal because the sample size was big enough.
Mhm.
Real quick, how big does the sample have to be so that the sample means make a normal curve?
Bigger than 30.
Bigger than 30. Right? Now, if it starts off normal already, I don't need sample to be 30 to make it normal because it's already normal, right? But if it's some, I don't know what it looks like, I need n to be greater than 30 to know that it's normal enough. Normal enough for what? Normal enough to use the chart of answers. Sounds like something you go on a quest to get. You must get the chart of answers. But I gave it to you, so you're good. Thank you, Nia.
I'll bring my ID next time.
Good. I won't have to throw you out.